Answer this question. Answer this question, and it says obtained by accurate drawing would not be accepted. Oh, so if you sketch the graph, that's not a solution. They said that we need to state the coordinates and the center. What's the center of this circle?
3, 4.
3, 4, nice. See, 3, 4, that easy. All right, what's the radius of this circle?
5.
Radius is 5, easy. Always remember that if it's in this form, it is in standard form, where the center is just going to be, this is the x coordinate at the center, this is the y coordinate at the center, this is r squared. So the radius is 5. So that's easy. It says find the tangent at 6, 8 on the circle. Now guys, if you draw an accurate sketch, them now go take it. All right? So just to draw a sketch and find the tangent at 6, 8. So pretty much you have one circle. I'm just going to draw a rough sketch of the circle. Maybe that is a circle and it has center 3, 4. I know that's not quite the center. And you have the radius, not the radius, you have the point 6, 8 right here. Let's call the point 6, 8 P. Right, this is 6, 8. And you want to find the tangent. All right, find the equation of the tangent. Now, I don't know why it is 7 marks, but to find the equation of the tangent, we'll first need to find the gradient of the normal. But the normal is any line that passes through any point on the circle and the center of the circle. So we can find the gradient of the normal, which is y2 over y1, y2 minus y1, 8 minus 4, over x2 minus x1, 6 minus 3. That will tell you that the gradient of the normal is 4 over 3. That's the gradient of the normal. Since this is the gradient of the normal, what we're going to end up getting now for the equation of the tangent, first you need to find gradient of the tangent, which is minus 1 over gradient of the normal. So the gradient of the tangent is negative 3 over 4. Once you get that, now you can write down that the equation of the tangent is y minus the y value at the point, y minus 8, equal to gradient of the tangent, negative 3 over 4, times in bracket, x minus 6. Now, you can leave your answer like this. Guys, you can leave your answer like this. Kate give you full marks for that. All right? Or you can simplify it if you want. All right? Simplify it if you want to just tell them that, you know, it worked out to be y equal to negative 3 over 4x. And then we know that minus 3 times minus 6 is 18. So that's 18 over 4. And then we'll bring over the minus 8 to have plus 8. But 8 is really 32 over 4. Originally I converted it was because I don't want to use a calculator. And so end up get y is negative 3 over 4x plus 50 over 4. That's the equation of the tangent. All right, that's the answer. That's the equation of the tangent. You can tell them that. And they're giving you 7 marks to do that. That's crazy. That is the tangent. All right? That would be the tangent right there. Nice. Now it says, calculate the coordinates of the point of oh, it's 4 marks. Oh, because I was like 7 would be too much. It says, calculate the coordinates of the points of intersection of C with the straight line y equal 2x plus 3. All right, so find the point of intersection with y equal 2x plus 3. We don't need much space to do that because that's simple. So you have the circle. Remember the circle is x minus 3 all square plus y minus 4 all square equal 25. Now guys, them give you this line. Them give you this line y equal 2x plus 3. So where y is, you can replace y with 2x plus 3. So you're going to end up get x minus 3 all square plus replace y with 2x plus 3. You're going to get 2x plus 3 minus 4 all square equal a 5 square. All right, so let's simplify and solve this now. We're going to end up get x squared minus 6x plus 9. And then now 2x squared is 4x squared. Now guys, you see that 3 minus 4 right there? Don't even bother write 3 minus 4, please. 3 minus 4 is negative 1, so just put minus 1. All right? So now that becomes second term square, which is minus 2 times 2 is 4, minus 4x, plus 1 square, which is 1, and that's equal to 25. So what does this work out to be now? X squared plus 4x squared is 5x squared. So we have 5x squared. Then you have minus 6x minus 4x. That's minus 10x. And then you have now minus 6x minus 4x is minus 10x. And then 9 and 1 is 10. But when you bring over the 25, 10 minus 25 is minus 15 equals 0. You can divide through by 2 to end up get x squared minus, all right, I don't want to squinge it. Let's do it the next page. Dividing through by 5, I get x squared minus 2x minus 3 equals 0. Then we factorize. We factorize, and what we end up get is 3, that is 3 and 1. Signs are different, the bigger number negative, minus, minus, x, x, plus, sorry. So end up get x is equal to negative 1, or we end up get x is equal to 3. If x is equal to 3, y, which is 2x plus 3, remember that's why 2x plus 3, so it's going to be 2 times x of 3 plus 3, which is going to be 6 plus 3 is 9. That is 9. So y right here going to be 2 times negative 1 plus 3, and that is, ooh, what is that? Negative 2 plus 3 is 1, right?
Yes, sir.
1. This is 1. So the points of intersection are minus 1 and 1, and minus 1 and 1, and 3 and 9. That's the point of points of intersection. All right, those are the points of intersection. So we have minus 1, 1. If you want to put it right here on the paper, points of intersection are minus 1, 1, and 3, 9.
So how come it is that you substitute a y equal to x plus 3 into the equation?
Repeat.
How come you substitute a y equal to x plus 3 into the equation, sir?
Why did I substitute this?
Yes, sir.
We substituted this because you have a line and you have a circle. So let me draw back the circle around. Here's a circle, right? Right, Adam?
Yes, sir.
You have the line y equal 2x plus 3. 2x plus 3 is a positive gradient. I don't know how that line look, but let's say it looks like 2x plus 3. Let's say the line look like this, right?
Yes, sir.
Then all it is saying is that the 2 points it intersect the circle is right here and right here. So in order to find those 2 points of intersection, we have to substitute the line into the circle. So where y is, we replace this y with 2x plus 3, right?
Okay, sir. So you basically are solving simultaneously.
We're solving simultaneously.
Okay, sir.
All right, so that's all we did. And solving simultaneously, we got that the points of intersection were those two around there, the minus 1, 1, and the 3, 9. 3, 9. That's it. All right, which makes sense.
Sir.
Nice. 3, 9 even work out to be directly above the center. Whoa. Yeah, man, we sketch relatively accurate. So this is the line y equal 2x plus 3. That's all that happened right there. Nice. All right, let's continue. So this now is part B is now vectors. These are the nice part of tricks. The nice part of module 2, I mean. It says the points P and Q are position vectors relative to the origin O, given respectively by minus I plus 6j and Q equal 3I plus 8j. Calculate the acute angle between P and Q. Now let's copy this and bring it to the whiteboard. Always remember a sketch is very good when you're finding acute angle. All right, so let's put that right there. So P is that and Q is that. All right, so this is P and this is Q. So if you want to find the acute angle between P and Q, just to give a sketch, P is the point minus 1, 6. Somewhere here is P. This is P. And Q is 3, 8. 3, 8. Somewhere up here is Q. All right, somewhere there so is Q. This is a 3 and this is a 8. Now what does this do for us? If this is 3 and this is 8 right here, and this right here is your minus 1, all right? So this is our P, this is our Q1. The acute angle between them, we need it when they're either both diverging or when they're both converging. All right, so the acute angle, let's call the angle theta, because that's what they said. If the acute angle is theta, then we know that the cos of theta is going to be equal to OP dot OQ divided by the magnitude of OP times the magnitude of OQ. Magnitude of OP multiplied by the magnitude of OQ. All right, so this is what we're going to have to do to get our 5 marks. All right. Now, in a case like this now, OP is just minus 1, 6. So in a case like this, OP is just minus 1, 6. Dot OQ, OQ is just 3, 8. Divided by the magnitude of OP is negative 1, is the square root of negative 1 square, which is 1. Plus 6 squared. I dash with a negative because even when I square negative, it's positive. Multiplied by, this is now 3 squared plus 8 squared square rooted. 3 squared plus 8 squared. So all we need to do now is simplify and put in our calculator. So that is cos theta. So let's evaluate the dot product. We get minus 1 times 3 is negative 3. Plus 6 times 8 is 48. 48 minus 3 is 45. So we end up get that the cos of theta is equal to 45 divided by, this is now 6 squared plus 1 squared is 36 and 1 is 37. So get the root of 37. And then we multiply that by the root of, this around here is the root of 3 squared plus 8 squared. 8 squared is
64 plus 9 to
64.
73, sir.
73. Sorry, I know I'm a little bit slower today. That usually happen on Mondays. Mondays are my not so swift calculating days. All right. So this is cos theta. So now we can take cos inverse to get the answer. So we work out cos inverse of 45. Work out cos inverse of 45 divided by the root of 37. times 73. All right, so that's what we're going to work out. So we're going to put that in the calculator. Cos inverse. Guys, the calculator smart. You don't need to put it in piece by piece. So calculator smart. Tired to say it, the calculator smart. Root of 37 times the root of 73. These calculators are smart. You don't need to put it piece by piece. Oh, it have the root under the root. Let me fix that. Root of 37 times 73. Cos inverse that, 30.01 degrees. All right.
And the calculator is smart, which is also a computer. You have to put in things
So we have to
correctly.
do what?
You have to put in things correctly, or it's going to be.
Yes, because it's programmed. All right. If you don't put it in, yeah, it can't detect the error that we made. All right. So 30.0 degrees, that's theta. That's the angle between them, which makes sense. Looking at our sketch, we could have deduced that it was roughly between, we know it less than 90. Yeah, we don't know say it less than 90. So we could have deduced that 30 is roughly true. It says, hence calculate the area of POQ. 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 So to find this area is, you know this side and you know this side. So if you draw just a line on it, this is POQ. So area of triangle is half AB sine theta. So do that. Area of triangle POQ. Area of triangle POQ is equal to a half of OP times OQ. Guys, I can make them know. That's what you're using. It's a half OP times the magnitude of OQ. I do something wrong. I put bracket when I should have put modulus, right? Because that's the length of the vector times the sine of theta. So that would work out to be a half of OP, the magnitude of OP, you see root 37 times magnitude of OQ, root 73 times the sine of theta. Theta is 30 degrees. Sine 30. You put that in the calculator, we don't have nothing to worry about. See it there? Guys, the calculator smart. A half of, in bracket, root of 37, close that bracket, times root of 73. They will multiply it by the sine of the angle, which was 30.0. Work it out, 13 is the area. That's how pretty it worked out. The area worked out pretty to be 13. And as Jemar said, you know, so if you don't put unit square it wrong. All right, you don't want to give it 1 mark after you work so hard. So just write the unit square. All right, 13 unit square. Nice. Now it says, find in terms of I and j, the position vector m, where m is the midpoint of PQ. Now if m is the midpoint, look what happened. That's why it's good to get a sketch in, guys. If m is the midpoint of PQ, m is the midpoint of PQ. This is vector PQ up here. M there's somewhere in between, here so. Right? M there's somewhere here so. If m is the midpoint of PQ, m there's somewhere right here. So the position vector of m, I can tell it look like probably 1, 6 or maybe 1, 7. It looked like 1, 7. Yeah? Just by my sketch, it looked like 1, 7. So now to find the position vector m, we know that OM is equal to a half OA plus OB. In this case, it's OP plus OQ. That's how we find midpoint. It's a half OP plus OQ. That's how we find midpoint. Average of the X, average of the Y. So the midpoint is going to be a half of OP plus OQ. Let's add OP and OQ. OP, which is -1, 6. So negative 1, 6. And these are being added to OQ, and OQ was 3, 8. Guys, see there just from the sketch. Me tell you 1, 7 in a look. Negative 1 plus 3 is 2. So it's going to be a half of negative 1 plus 3 is 2. 6 plus 8 is 14. Half of 2 is 1. Half of 2 is 1. Half of 14 is 7. So you get 1, 7. Nice. Cool with this? That's the midpoint. Now, guys, them give it in IJ form, so you can't leave your answer. So if you leave your answer so, you get 1. So you have to put that it is I plus 7J. That's the midpoint. I plus 7J. All right? I plus 7J. So this right here, M is I plus 7J.
Sorry, the formula for area is half AB sine theta, right?
The formula for area of triangle? Yes, half AB sine theta.
So you put the actual points. So it's the dot product times the sine theta. Or is the magnitude? Right?
It's the magnitude. A and B are the magnitude. So it's a magnitude of the vector OP, magnitude of the vector OQ. This is your A, this is your B, times the sine of the angle between them. All right? Cool with that?
All right. So
Now, guys, it says now R, find the position vector R such that PQRO labeled clockwise forms a parallelogram. PQRO, P, Q, R, there's somewhere over here, so I can tell you that it is 4 something or 5 something. R, there's somewhere here, so, but them say PQRO for find a parallelogram, I need to find out what R is. So this would be R. In order for it to be a parallelogram, this is how parallelogram must look. Yeah, this is how parallelogram must look. But guys, if R is a parallelogram of what? 2 pair of parallel sides, no? Yeah?
Yes, sir.
See, we have to know C-set maths. If R is a parallelogram, then we know say OQ have to be parallel to RQ, though? Right? And putting on a different color now, let's go through blue. Then we know say PQ supposed to parallel to OR, though? Yeah?
yes, sir.
That makes sense?
Yes,
Yeah,
sir.
man, so can we do that now? So since they're parallel, we know that OP supposed to be equal to RQ, and then OR going to equal PQ. So guys, we're not done. Let's write that down. That OR are going to end up equal to vector PQ in order for them parallel. To go equal to vector PQ. But vector PQ, already know what's PQ. PQ is OQ minus OP. Oh my God, this is so easy. OQ minus OP. What is OQ? OQ is the point 38 minus OP. OP is the point -1. -1, I think this was -1, 6 was OP. Let me go back and check. Yeah, -1, 6. So 3 minus -1 is 4. 8 minus 6 is 2. And so that is R. R is a point 4, 2. But you can't leave it like that. Them say put it in the IJ form. So it is equal to 4I plus 2J. All right, 4I plus 2J. That would make it be a parallelogram. All right, so this point right here, R, is 4, 2. That would make it be a parallelogram, because a parallelogram of 2 pair of parallel sides, this distance down here supposed to equal to this distance up here. This distance over this side supposed to equal to this distance. Remember when we started coordinate geometry, I said Remember what we said when we had our first in-person class? We have to know the properties of parallelogram. We have to know the properties of square. We have to know the properties of rectangle because them can throw them in at any point. Guys, don't forget, not what me tell you, guys, can't forget. Can't say I didn't tell you, so we have to know property of a parallelogram. I did say it, don't it? All right. So we can't forget that. All right. So everybody clear with this one?
Yes, sir.
All right.
Yes, sir.
Nice. So we can't forget the properties of parallelogram, guys. All right. Two pair of parallel sides.
So while we're on the topic of parallel lines, the unit vector for parallel lines is the same.
Unit vector.
I don't know.
The unit vector for parallel lines.
There's something about same in there somewhere.
All right. Let's talk about unit vector in general. If you're talking about unit vector, what explicitly we want to know about unit vector? We know that any unit vector, I don't know.
I'm asking if there's a way to identify parallel lines without using the direction.
Without using the
Like
direction. Yes,
for like plain questions.
There are two ways that repeat.
For certain questions where they don't give you the direction, but they say lines are parallel, and we're just there like,
So we're gonna book a question like that in 2011 paper. All right, so we can do that next week. It's when two lines are parallel and you can't use unit vector. Then what you need to know is two lines are parallel if the angle between them is 0, because parallel lines never intersect. So this is another thing you can use both parallel lines. All right, parallel lines never intersect, so the angle between them is 0.
okay. So,
Yeah.
sir, what were you gonna say about unit vectors?
Oh, I was going to say that you can use the unit vector. Once two lines are parallel, they have the same unit vector.
Oh, so that method would have worked as well.
All right. Yeah.
I don't know what I was doing on that. I went into a rabbit hole and couldn't solve it.
All right. No problem. I think it's a past paper you're doing, and you just have to apply one of those two with unit vectors or parallel lines. All right.
So if it were that it is the angle is 0, that means that theta would be 0, and then I just do cos inverse. No, I can't.
And the cos of 0
cos of 0 is 1.
Is 1, and so the dot product over the magnitude of A times the magnitude of B would be 1, and then you can set up that equation and solve for whatever you want.
Okay, I see.
All right, by transposing. All
Hmm.
right, nice. Now question 4 is fully a tricks, guys.
I don't remember what year that was, so.
All right, now this one is fully a trig, question 4. So question 3 was coordinate geometry and vectors. Question 4, fully trig. And this says now, show that x equal 4 cos theta plus 9 sin theta. I gave this on a classwork already, so it's quick to do. Remember I said to find x, we need to break this up. Break this up right here, so. Right, and by breaking up it into two triangle, right? Let's say we break it up in two triangle like this. We can call this piece right here, right? This piece right here, we can call it, I don't know, let's call that piece R, yeah? And then we can call this piece right here, so this is, I don't know, call it some other letter. Let's call it Z. So X is equal to R plus Z, right? X is R plus Z.
Yes.
So we'll call this R and we'll call this Z. Now in this triangle now, since we know R and we know 9, once you know opposite and hypotenuse, you know that the sine of theta is the opposite of R over the hypotenuse of 9.
We don't know
So
theta.
transposing, we end up get R is 9 sine theta. That's what you do right there. So ending up can put say X equal to the R right there, so which is 9 sine theta. And then in the smaller triangle now, we look at it and we say, we have adjacent and hypotenuse. So we know that the cos of theta would be equal to the adjacent of z over the hypotenuse of 4. So to make z the subject, we should say z equal to 4 cos theta. Yeah? Yeah, man, easy stuff. Z is 4 cos theta. So this would be z right here, 4 cos theta. Once you get that for z, we can write that down right here. So now, say x is 9 sine theta plus 4 cos theta. That's what we say is x now. And so now we're cool. This is x, 9 sine theta, 4 cos theta. And we're showing it. See it there? Shown. All right, same thing. All you need to do is flip the order, but addition is commutative, so you leave it like that. Now the next thing it says now is by expressing x in the form r cos theta minus alpha, where r is positive, find the maximum values of x. Now that part I didn't put on the classwork that we did.
This
I don't
is
know
a
why.
classwork? Wow.
Repeat.
This is on a classwork?
We did it in the classwork when we were doing trigonometry. You don't remember?
Oh, so you know much
Well,
work.
not a graded classwork. A classwork we went through together in class.
Sorry, you got to work, you know, sir. I'm just.
Yeah. So let's look at this now. So x is 4 cos theta plus 9 sine theta. 4 cos theta plus 9 sine theta. All right. And so now if this is x right here, we can just, put it in r sine form. Find out what is r. R is the square root of 4 square plus 9 square. We know that will be r, which is 9 square is 81, 4 square is 5, 81 plus 4 is 85, square rooted.
Sir?
That wrong down.
Yes, sir. 8 1
That's
plus
crazy.
16.
This is what?
8 1 plus 16 is 7.
97?
Yes, sir.
Nice, nice. Thank you. All right. I tell you, Monday is my off day for calculating. So alpha is now tan inverse of 9 over 4. I'll make sure to use my calculator for this. All right. I won't be checking it. Tan inverse of 9 over 4. I will end up get tan inverse of 9 over 4 is 66 degrees, but they want it in radians, so I need to change the mode. I need to change the mode to radians and work it out 1.15. So alpha is equal to 1.15 in radians. All right. Now it says express it in the r cos form. So you have to end up telling them, say x is equal to the root of 97 in bracket cos of theta minus alpha minus 1.15. I will close it. That is it. Now you never need to put them bracket here. Me just want to put too much bracket. Just put root 97 times cos of that. And if you put so much bracket. All right, so this is x. Root 97 times the cos of theta minus 1.15. Then it said us to do something else. They said find the maximum value of x. To find the maximum value of x, what's the maximum value of x? What's x maximum?
The value of r.
The value of r. So x max is just root 97. That's the maximum value of x. The root of 97. That's literally it. And did they ask for the value of theta 4, which is maximum? No, that's it. Imagine they're literally giving you 6 marks to do nothing. This is 6 marks. Oh, so nice. 6 marks for this. Yeah, man, we'll take this any day of the week. All right. Cool at this part. Let me show the screen again. So cool at this.
Sir, could you just go one more time, please?
All right, no problem. All right, so first thing we need to do is, it said that we're supposed to express it in the form 4 cos theta, express it in the form r cos theta minus alpha. Yeah? Cool with this part? We need to express it in this form?
Yes, sir.
Express it in this form, the first thing we need to do is we need to find r. Remember what we said by the definition, the formula? Think of this as A and B. So R is equal to A square, 4 square, plus B square. And so A square plus B square square rooted, give you root 97, that's R. Yeah? Cool with that?
Oh, I see it now, sir. I see it now.
Yeah, and then alpha is tan inverse 9/4. Then once we get A and B, we just plug it back right here. Once we get and alpha, you plug R right here, root 97, alpha right there, which is 1.15. Then to find the maximum value, as Jovan said, maximum value is R. Maximum value is always R, so it's the root of 97. All right, nice.
Sorry, so 6 marks them normally give for this, like when them normally ask it.
No, they usually give about 4, but I think they give 6 marks because when they ask for the maximum value of X, this add in a 2 marks to it. To express it in this form is 4 and 2 marks to find the maximum value of X.
Oh, all right.
So that's how it balances back to 6. All right. Now look at this now. It says given A and B are acute angles in a triangle such that the sine of A is 3/5. Guys, anytime you get them question here, please draw your triangle, yeah? Please draw your triangle, guys. I'm begging you, draw your triangle. Then tell us that the sine of A is 3/5. So write it down. Sine A equal 3/5. If you can't remember what is sine, write down SOHCAHTOA. Say write down so. Oh, sine is opposite over hypotenuse. So you draw your triangle and put your angle as A. A. The opposite to A is 3. The hypotenuse to A is 5. So then you know the adjacent must be 4. Because 3 square plus 4 square is 5, don't? Right?
Yes,
Cool with
sir.
that? Yeah. So that must be the adjacent. Now, let's look at this now. It gives you a next triangle and say the cos of B is 5/13. So you can use you have 2 color pen. You use our next color now and say, oh, you have 5/13 and that is B. So write that down. The cos of B. Then if you can't remember what cos is, write down SOHCAHTOA. I'm telling you, it works. It don't matter if you have to write down SOHCAHTOA. So then you can say, oh, the adjacent is 5 and the hypotenuse is 13 by writing down SOHCAHTOA. So then now the opposite have to be 12, right? Because 5 square plus 12 square is 13 square, right? So this have to be 12, right?
Yes, sir.
Yeah.
All right. I'll save this for when we come in on Wednesday, sir.
Repeat.
I'll save the question I had for when we come in on Wednesday.
Okay. All right, no problem. All right. Make sure and just any question you have, Jovan, at exam time, at exam time. So write down all your questions for Wednesday and we can go through them even after class, all right?
Yes, sir.
All right, so guys, write down your question then when you come in Wednesday. So look at this now. We want to expand sine of A plus B. Cool? So we want to find the sine of A plus B. So if you want to find the sine of A plus B, it said do it without a calculator. Anybody will find angle A and angle B and then find the sine of it? Wrong. They want you to find it without a calculator. So you're going to have to use this right here, expansion of trig. I know a lot of us don't like it, but the sine of A plus B is the sine of A cos B plus the cos of A times the sine of B. All right, please remember that's the formula, that's the expansion. So this can just work out to be now, what was sine A? Sine A was 3 over 5 times the cos of B. What was the cos of B? The cos of B was 5 over 13. Then now we need cos A. Now this is where it is weird. You need cos A. Cos A is adjacent over hypotenuse. So in the first triangle, the adjacent is 4 over the hypotenuse of 5. Then you need the sine of B. The sine of B is opposite of 12 over the hypotenuse of 13. And now you can simplify this. Now we all know that this 5 right here, this 5 here, so, well, let me not cancel it now. 5 times 3 is 15, plus 4 times 12 is 48. And then it's all being divided by same denominator. 5 times 13 is 65. So that works out to be 15 plus 48 is 63, right? Yeah? 63 over 65. All right, that's what we get. 63 over 65. That's the sine of A plus B. Now, guys, just if you want to test the answer, if you want to check for see if this is really the sine of A plus B, I would say you can find what A is. So look at this. If you put a calculator back in degrees, and you find A, so if sine A is 3 over 5, you go sine inverse 3 over 5 to get A. So A is 36.9. If A is 36.9, you can find B2 by taking cos inverse 5 over 13. All right, and so this is where you get 67.4. So if you add this to what was A, which was 36.9, that would be that would be A plus B. This is A plus B. Then you find the sine of that to get the sine of A plus B, which is 0.969. Now look at our answer. 63 over 65 is 0.969. So that shows our answer correct without finding A and B. All right, so you can do that to actually check to see if you answer right. All right, so we're good with that one. Tick. No need to find the cos of A minus B. The cos of A minus B, we just need to remember that formula. Cos of A minus B, remember it's cos plus sine. So it's going to be, yeah, cos A cos B plus, always remember when it's a minus in here, then it's a plus out here. Cos A cos B plus sine A sine B. All right, sine A sine B. So now all we need to do is work this out. The cos of A, looking at our diagram, the cos of A is 4 over 5. We already know. Cos of A, 4 over 5. Times the cos of B, we already know, 5 over 13. Plus the sine of A is 3 over 5. Times the sine of B is 12 over 13. Let me check again, 12 over 13, that's the sine of B, yeah. And so we'll work this out now. No, I'm not a big fan of canceling. I'm a big fan of expanding the numerator. 4 times 5 is 20. 20 plus 3 times 12 is 36. 20 plus 36 over 65. That's 56 over 65. That's the answer. Easy. Soft. That's the cos of A minus B. Cos of A minus B is this. All right, nice. Now, guys, there's something that it asks next that I really like. And I really like this one because you can do it with multiple ways to do it. Cos 2a. Cos 2a is 3 formula. And I feel like we can write out all 3 of them. Right? So if you want to find cos 2a, tell me the first one.
Cos squared theta or a
Cos square a, don't say theta cos of a. Cos square a minus.
minus sine squared a.
Very good. Now look at this. We already deduced that cos a from around here was 4 over 5. So you can write that down, that cos 2a would be 4 over 5 square minus sine square a. Sine a was 3 over 5, so it's 3 over 5 all square. So if you work this out, what you get is 4 square is 16 over 25 minus 3 over 5 square, that's 9 over 25. 16 minus 9 is 7 over 25. That's one way you could get cos 2a. Now, guys, just to verify that the answer right, look at this now. Another way you could do it was to use the next formula. What's the next formula? What's the next formula?
Cos squared a minus 1.
2 cos square a minus 1.
Cos a, 2.
Not cos square a minus 1. 2 cos square a minus 1. All right, so we know cos a is 4 over 5. So it's going to be 2 times 4 over 5 square minus 1. And look how much beautiful. 4 square is 16 over 5 square is 25. So that's come 2 times 16 over 5. 5 square is 25. Oh, then minus 1. Guys, to write minus 1, I'm going to write 25 over 25 because I can't bother to use a calculator. 2 times 16 is 32. 32 minus 25 is 7 over 25. So that's another way you could have done it. See the same answer. Or, I know it is 2 marks, but why am I writing out all of the or them? So remember the cos 2a formula. Because we see earlier today, they're important for trigonometry, they're important for differentiation, they're important for integration. So we have to know all 3 of them. That's why I'm writing out all of them. So cos 2a is also 1 minus 2 sine square a. So that would be 1 minus 2 times sine square a. Sine a was 3 over 5. So it's 1 minus 2 times 3 over 5 square. 3 square is 9. 9 times 2 is 18. That would become 18 over 5 square is 25. So it would be 1 minus 18 over 25, which is 7 over 25. Anyway, you get it, that is cos 2a, 7 over 25. Or maybe you want to put it as a decimal, and so say you'd get 7 times 4 is 0.28. That's what it would be as a decimal. Now look at this. This is cos 2a, 0.28. Say they just want to use a calculator, right? And say, just to check if you answer right. I'm a big fan of checking your answer. You find what a is. Looking at the question, we find out what a is. All right. I don't know what just happened there. Let's go again. So I'm a big fan of finding out what a is. So here it is. Look at this. We're going to find out what a is. To find out what a is, you have sine a is 3 over 5. So we'll take sine inverse of 3 over 5. That will allow us to find what a is. That's 36 point blah, blah, blah. When you multiply that by 2, that would be 2a. Now we can find cos of that right there. 7 over 25. Oh, so nice, man. Just as to say cos 2a is 7 over 25. So that verifies our answer. All right? Nice. Now, guys, you see this question right here? This question, Cape said 0.2% of the Caribbean got this right. 0.2. Meaning if 100,000 Pitney do Cape exam, let me show you 0.2. All right, I want you to actually see 0.2. What is 0.2? 0.022%. No, 0.02. 0.2, sorry. 0.2 of 100,000. What's 100,000? So much person get it right? Oh, 0.02%. You'd have to divide by
You have to
100.
divide by 100. Yes,
Yeah,
sir.
divide by 100. Sorry, yeah. And then we'll multiply it by 100,000. By the way, more persons do pure math than this. I'm just saying. 200. So pretty much 200 Pitney getting right this right in the Caribbean. And probably 10 in Jamaica. If so much. Probably less than 10. All right? Probably more than likely persons from Trinidad getting this right. So we need to prove that tan of x over 2 plus pi by 4 is equal to sec x plus the tan of x. Now I'm not gonna lie, guys. This question was challenging, all right? I actually, just a while ago, I was looking at it, I was like, whoa, this was really challenging. What I had to do to get to this wasn't normal. And the reality is, I can't prove this equal this. So what we're gonna do is we're gonna prove this equal this, but then do it the reverse way. All right? Does that make sense?
Yeah, say this right. This the second.
We're gonna write this equal this. We're gonna write out what this is to this, and then now we're just gonna switch back the order to write that left hand side equal to the right. All right?
Yes, sir.
That's all we're gonna do. Because you can't prove your right equal to your left. That don't answer the question. We can expand out your right to get the left and then write it back in the opposite direction to end up say left equal to your right.
Okay,
So that's how you do this one, all right?
sometimes I think Cape sets questions for people to fail.
No, Cape said question to distinguish boys from men. All right? Yeah, man, it's a pi by 4 throw it off. That's why, because this is going to give you a numerical value. And that numerical value, throw it off. So let's do this question right here. As I said, it was a little bit spicy. All right, it was a little bit spicy. I'm not gonna lie to you. That was a challenging Cape question. This is a challenging Cape question. The tan of x over 2 plus pi by 4 is equal to sec x plus tan x. All right, now let me see which way I can take this on from now. As I said, now the pi by 4 here throw me off. So what I'm gonna do is start from the right hand side. All right, so this is not part of the proof. We don't start the proof yet. All right, we can't write right hand side. But what I'm gonna do is just expand the right hand side. Sec x is 1 over cos. All right, this would be 1 over cos x. Plus tan x is sine x over cos x. All right, I'm just trying to make this make sense. All right, now what this will work out to be is 1 plus sine x, 1 plus sine x over cos x. Now for some reason I need to generate, guys, I'm trying to generate x over 2 here. All right, let me see how I can. All right, look at this now. All right, follow now, guys. This is where we have to be thinking a lot. Remember this, sine square a plus cos square a equal 1, right? Right, guys? Yeah?
Yes, sir.
So now you see this 1 right here? I'm gonna rewrite 1 as, guys, don't laugh at me and don't say, sir, that's crazy. I'm gonna rewrite 1 as sine square x over 2, you might say, sir, why x over 2? Because this is what I'm trying to generate. I'm going to rewrite 1 as sine square x over 2 plus cos square x over 2. Plus, now guys, look at this. This is sine x here, so I'm going to write sine x as sine 2 times in bracket x over 2, so I can use double angle formula. Does that make sense? This makes sense? We see that this part is 1, right? And also, we see that sine 2 times x over 2 is a sine of x, right? Because the 2 cancel the 2 is still sine x, right?
You're being very manipulative of the formula.
And then cos x is also the cos of 2 times in bracket x over 2. Cool it is? Cool it
Yes,
that?
sir. Yes, sir.
All right, now let's continue.
So, see what you do, but I'm gonna see why you do.
All right, no, good question. Now, why am I doing it? I'm trying to do this, Roshan, because you see that x over 2 here? The x over 2 here is what we want, we want everything in terms of x over 2. All right? That makes sense?
Yes, sir, but all right, sir, continue.
How would you generate the pi over 4?
How we're going to generate pi over 4? Easy to generate, because remember the left-hand side would be tan A plus tan B. The tan of pi by 4 is 1. So at some point, we can always add 1 and subtract 1. We don't have to worry about the 1. We just need to worry about how we're going to have everything in terms of x over 2. All right?
Sir.
So that was my biggest worry. Get everything in terms of x over 2. So we'll do the hard yard first. Now, guys, it's simplifying now. So simplifying now, we're going to have sine square x over 2 plus cos square x over 2. Then we can use the double angle expansion now. Sine 2x over 2 is going to be 2 sine x over 2 cos x over 2. Finally, we have the numerator entirely in terms of x over 2. Because I have 2 sine x over 2 cos x over 2. We're almost there now. And this is being divided by cos 2 times x over 2. It doesn't matter which one you use. I am going to use cos square x over 2 minus sine square x over 2. All right? Now you might say, why, sir? Why use this one? Cos square x over 2 minus sine square x over 2. I'm going to show you why now. Now look at this. If this was like A and this is B, guys, follow me, follow me. If sine x over 2 was like a and cos x over 2 was like a B, this would be a squared plus b squared plus 2 times a times b. Now, guys, what is a squared plus b squared plus 2ab? Isn't that equal to a plus b all squared?
Yes, sir. Sir.
Blouse and skirt, when I see. So in the numerator.
Wait a minute, sir. Wait a good. Wait.
Sir, what would you put it?
Roll back, please. Roll back, yes, please. Roll back, please. Roll back.
Yeah.
You are saying that the interior angle, or are you saying the actual entire trig function?
No, I'm saying right here, so follow me now. Let's actually make the substitution then. Look what I'm saying. Oh no, how do I get this back?
What happened?
Accidentally click delete. How do I get it back?
There should be a read.
Okay, just went to the next sheet for sheet 13.
How do I go forward?
There should be an undo option, sir. So
Undo, where's undo?
are you on Internet Explorer, sir?
Oh, nice. Guys, nice. I learned something today. Nice. All right. So now look what I'm saying now. If you use this as A, right? Let me put it in a box right here. If we let A be equal to sine x over 2, call that A. Then that means that A square would be sine square x over 2. Follow that part? Then if we call B cos x over 2, then what is B square? Cos square, don't it?
Yes,
right?
sir.
And then that means you still have your A and your B here. So now I am saying that A squared plus B squared plus 2AB that equal to A plus B all squared, don't it? Right? That makes sense? This makes sense?
But yes, sir, but hold on, put it to like 10 now, though.
No, look it now. Just follow now. Don't worry, man. Don't worry. I see something you're gonna see it soon too. I'm not gonna lead you astray. So now A plus B, just write this now. A plus B is the sine of x over 2 plus the cos of x over 2. And this is being all square. All right? I hope what I saw did make sense. I'm just hoping. All right? Let's see
Yes,
now.
sir.
In the denominator now, cos square minus sine square is the difference of 2 square. Ah, at least it made sense. The difference of 2 square can be broken up as the cos of x over 2 minus the sine of x over 2. And then this is being multiplied by cos x over 2 plus sine x over 2. Right? That's how we break up the difference of 2 square, right? You follow this? You follow this, guys? Follow this?
Sure.
Yeah.
I got that's it, but
Let's
yes,
go
it
back.
has to be
Let's go
with
back
the-
to make sure follow. This is a difference of 2 square. Remember, A is cos x over 2, B is cos x over 2, and A is sine x over 2. If you have B square minus A square, isn't that B minus A times B plus A? Right here. In the denominator.
yes, sir. Say that, but
That's what I put right here. Difference of 2 square in the denominator, right?
yes, sir, because you want to try
Now,
and
guys, look at this in the numerator. If you square in the numerator, instead of writing the square, I could have actually put times itself, the sine of x over 2 plus the cos of x over 2, though.
yes, sir.
Then that now go cancel with one of them from the denominator.
Yes, sir, but that wait, that means you're left with the 2 sign thing on the other
So
side.
this gonna cancel this. So gonna left back with this plus this over this minus this. All right, cool, nice. Now guys, this is how we're gonna generate with tan now. We're almost reached there. So now we have sine x over 2 plus cos x over 2. And this is being divided by cos x over 2 minus sine x over 2. Guys, we get it now, you know, we get it. Now, if you divide through the numerator by cos x over 2, so we're going to divide both sides by cos x over 2 now.
But that's the numerator alone.
If you divide, no, write it as divide numerator and denominator. So you're dividing the numerator now and the denominator by cos x over 2. The sine x over 2 over the cos x over 2 will give you what? That will give you the what? Sine over cos? That will give you the tan x over 2. You see it now, Rashan?
Yes, sir.
Yeah, man. Now look at this now, guys. The cos x over 2 over the cos x over 2 is what?
I don't know. Wait.
No one.
Yeah.
Over. Look at this now. The cos x over 2 over cos x over 2 is 1. Minus sine x over 2 over cos x over 2 is tan x over 2.
Sir.
Yeah.
I'm not comfortable with skipping so many steps.
Repeat.
Skip steps. I don't know.
Oh, I skipped the step. You're not comfortable with this?
No.
All right. So since we're dividing, all right, let's write it out then. All right. We're gonna divide through each term. All right. Let's not skip the step. So we're gonna divide by cos x over 2. I'll put it in words now. Divide through by cos x over 2. Dividing through by cos x over 2, Mr. Platt, as we're going to get right here, is the sine x over 2 over cos x over 2. They agree that that part is tan x over 2, right? Yes, Mr. Platt? Yeah?
Yes, sir.
Then you're
Yes,
going to have cos x over 2 over cos x over 2. You agree that that part going to be 1, right? Over cos x over 2 over cos x over 2.
one again.
You agree that this is 1, right? Yeah?
Yes, sir.
And then minus sine x over 2 over cos x over 2. That is minus tan x over 2, right?
Yes, sir.
So do you feel better now? You feel better now that we write out the step? Feel better now, Mr. Platt?
Yes, sir.
All right, good. Oh, I need to write my 2. All right, so this is what we have now. No, Roshan, as we were saying, don't worry about the tan pi by 4 because 1 is the tan of pi by 4, though. So can't we know, right, that this is the tan of x over 2 plus 1, which is tan pi by 4, though? Right?
Yes, sir.
Yeah, man. And then this one right here, so now is over tan pi by 4. This one right here, no, leave the one there. You don't need to trouble this one right here. All right? Well, you can. You can tell him now where this is now our tan pi by 4. Or actually, just leave that one here. Leave that one. 1 minus tan x over 2. Let me tell you why I want to leave that one. Because I want to substitute the compound angle for tan. All right?
Yes, sir. So should you just leave the one and then?
Yeah, just leave this one in the denominator. Because remember, this tan pi by 4 is 1. So let me write a note of it. Recall, tan pi by 4 is 1. So guys, you'd have had to know this identity that the tan of 45 degrees is 1. I always tell you guys, know them. Know them. Because if they put a trick proof with this, it will rough you up if you don't know it. You have to know tan 45 is 1. Now you might say, sir, why you put tan x over 2 times tan pi by 4? Because tan pi by 4 is 1, I can multiply 1 times tan x over 2 and it won't change the value. Because then this will allow me to say that this is the tan of A. See here, it's tan A plus tan B over 1 minus tan A tan B, which is the tan of x over 2 plus pi by 4. Now, guys, when I start prove the question here, we just make sure say it correct. Now, what I'm saying that you would write on an exam paper is now, after you do this like on the side of the paper, write it this way now. So the tan of this equal this, then I write this line equal this, then I write that line equal this, then it 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 give you right hand side, then it give this. Does that make sense? You just write the line then back way because it's difficult to prove from left side to right. Why is it difficult? It is difficult, guys, because it starts with pi by 4. So we have no idea of our end destination because the tan of pi by 4 is 1. But if you start with the end destination and show, say, it's your left-hand side, you can then write it the reverse way from the start point to the end destination. But we couldn't start with the start point because the tan of pi by 4, guys, is 1. And 1 gonna always make us skewed with what we're gonna do. There's so many things we can do with 1. We can write 1 as sin x over sin x, cos x over cos x, sine square plus cos square. We just don't know how it end up reach our right hand side. We don't say, oh, I dash with the x over 2 to get x, just a regular x. But if you start from your left hand side and break it up into double angle formulas, you can easily get to your end destination. All right, so cool with this? So this is our left-hand side, and I'm gonna write it down in words that this is not the proof. You would then have to write your solution backwards. I can't bother to write it backwards, that's a lot of work. You would then write the solution backwards. Guys, you understand what I mean by backwards, right?
So we start off where we got it. Then
Yeah, where we got it, and then go that, then that, then that. Good. And that would be the solution. We cool with this?
So the 10, the denominator, so the 10/4 is just when you add 1t, right?
This part where I put this in bracket?
Yes, sir.
No, the only reason I put this bracket in, put that part in bracket, Javon, is because we have to remember this.
No, sir. Like how you got it down there, that's the problem I have.
No, this, let me explain. That's what I'm gonna do. I'm trying to write it in this obvious form. Tan A plus B. What's the formula for the tan of A plus B?
Tan A plus tan B.
Yeah.
And since it's plus, in the denominator, I have 1 minus the product of tan A, B.
Tan A, tan B, good. So since this is the tan formula now, Javon, what we need to realize is that I'm gonna have to write the tan of pi by 4 right here because the tan of pi by 4 is 1. I can always write tan x as tan x over 2 times 1, can't I? But then 1 is what? Tan pi by 4. And then that's when I can substitute that this is my A and this is my B, right? You see it now?
Yes, sir.
That's how I end up can substitute it as this. We cool it
So
this,
we
guys?
need- yes, sir. So we really needed the entire simple angle formulas.
All right.
I know what tan pi over 4 is and tan pi over 6 and so on.
All right. Yeah, man. Cool. All right. Now, guys, what we're gonna do is, as I say, I really want to practice more old paper.